Hello everyone and welcome to this new LATI webinar. The topic of the day is quite interesting. We are going to talk about how the future of our appliances will be in the track of recycling and repairing, and how company LATI is willing to create new and modify materials in order to let this process happen quite easily. The agenda of the day is quite crowded. We wait a couple of minutes more in order to let everybody join this webinar. The room is quite crowded, so in a few minutes we will jump into the topic. Well, the agenda of the day is divided into three main branches. During the first half of this webinar, we will give a look at the fundamentals of sustainability, and we will try to understand what makes plastic materials not sustainable or sustainable. Then we will try to understand how we have to think and design the appliance of the future, and at the end we will see some conclusions and some perspectives for the forthcoming applications. At the end of the webinar, please, I will welcome any question you may have, and then during the next couple of days, we will upload this webinar on our YouTube channel. Please subscribe in order to see not only this one, but also the already gone webinars. So first of all, let's introduce some of the most important concepts of sustainability. First of all, we have to redefine what is sustainable. We know that is sustainable every process, material, or application that uses in an efficient way raw materials and energy. We have to keep this in our mind. So use efficiently raw materials and energy. The second concept is the so-called life cycle assessment. What is the life cycle assessment? It's a quite complicated process allowing us to evaluate the impact on the environment of a process, an application, a product, or a service. This is a quite complicated evaluation. The third concept is the so-called global warming potential. The global warming potential is expressed as kilogram of CO2 equivalent and is calculated and defined for every product, process, or service. All these topics are quite familiar here at LATI. We strongly believe in the track of sustainability, and that's the reason why we have just achieved the very important goal of the platinum medal EcoVadis for at the highest ranking of sustainability. Now let's give a look at LATI materials and global warming potential. Let's try to understand what is the impact on the planet, on our environment of three typical flame retardant compounds. We have taken three very popular grades, three winning grades made out of polyamide 6,6, 25% glass fiber, and flame retardant using brominated polystyrene, the so-called V0CT1, aluminium diphosphonate, the so-called V0HF1, and red phosphorus master batch, the so-called KB. The global warming potential for those plastics per kilogram of finished product is a number between 6 and 7 kilograms of CO2 equivalent per kilogram. Please note that these numbers are not obtained by using a very simple, straightforward online tool. We have a dedicated software, a dedicated database, and our calculations are extremely accurate. So these numbers are to be considered as extremely reliable. If we move from this evaluation per kilogram of finished product to the evaluation per cubic decimeter or liter, so the volume of the application, then we will see that these numbers are skyrocketing because of the density of the material. So per every liter of the foretold flame retardant materials, the global warming potential is increased to 9 to 10 kilogram of CO2 equivalent per liter. So you see how impacting is every kilogram of flame retardant plastic that you put in your project. Now, let's try to understand where does this global warming potential come from. Let's try to understand how to split the whole process of creating 1 kilogram of flame retardant plastic and try to understand where does this global warming potential come from. We have done this exercise with the university, and we have tried to keep track of everything happening from cradle, so from the very beginning, from the creation of raw materials to gate, to our logistics gate. So we have studied the whole process from the raw materials to the finished product, to the finished LATI pellets. We have divided the whole process into 3 streams: the upstream, including global warming potential related to raw materials and packaging of raw materials; the core process, that is our extrusion process; and then the downstream, which is the logistics, bringing our materials to the gate. What we have found is that for a material like this one, so for a nylon 6 20% glass halogen-free flame retardant, having a global warming potential of 7.9 kilogram of CO2 equivalent per liter, it is possible to evaluate the impact of every kg of this material on human health using a very specific system called Echo Point, whose definition is just the one you see here below, is the environmental impact of every European citizen. It is possible to evaluate how every stream impacts on this global warming potential, and what is found is that the biggest portion of this impact is due to the upstream. So the biggest portion of the global warming potential of 1 kg of this very material is related to the production of raw materials. So the biggest issue is coming from the production of raw materials, not by extrusion or transport. It is the production of plastic in itself that is harming the environment. Let's try to understand which raw material is actually impacting the most. We have done this exercise on this very material, and what we found is that the main component of the compound do not impact the same way. The biggest impact is due to the production of nylon 6. It's not the glass fibers, it's not the flame retardant system. The global warming potential is coming from the production of the plastic material. The nylon 6 in itself impacts for close to 85% of the total global warming potential. This is a very important piece of information, because everybody may think that it's up to how you produce it, to what kind of electric power you use it. No way. It's the production of the plastic in itself that is actually creating the biggest chunk of the whole global warming potential. So now let's introduce our partner here, the vacuum cleaner, and let's try to understand how global warming potential relates to an appliance like a vacuum cleaner. So for a vacuum cleaner, what we know, and the source is the one reported here below, Open Repair Alliance, what we know is that 80% of the global warming potential generated by a vacuum cleaner during its whole life, 80% is happening during the production of the vacuum cleaner in itself. So by its manufacturing, creating the vacuum cleaner, assembling the parts, molding the plastics, creating the plastics, that part of the process is creating 80% of the whole global warming potential. The second piece of information, which is very important, is the life expectancy of a vacuum cleaner. Vacuum cleaners are expected to last more or less 8 years. Some of them may last a little bit more, but that is the average life expectancy of a vacuum cleaner. What happens when vacuum cleaners stop working? What is the most popular failure cause? The first failure cause is a broken electrical cord, 24%. Then we have failure in the electrical motor, 14.5%, failure in other electrical parts, 13%, and the failure of the switch, 8%. All of you know what happens when the vacuum cleaner stops working. We just dispose it. Most of us do not even attempt to repair it. But if we wanted to try to repair it, we would find that 57% of the vacuum cleaners that have been submitted for repairing attempts have been actually repaired, and 18% more should be repairable if necessary information or tool were available. This means that 75% of the broken vacuum cleaners may be repaired. And this means that 3 vacuum cleaners on 4 broken vacuum cleaners could go back to their working life, reducing the global warming potential related to the manufacturing of the vacuum cleaner in itself. What are the most popular issues that are an hindrance to repairability? The most common issue is not having the spare parts, 24.7%. The second one is related to the assembly, to the design of the device in itself. It is impossible to open it. It is impossible to disassemble it. Some of the parts are not accessible, and this means that it is not convenient to fix it. And then we have an excessive wear of the material in itself, wear or failure related to material degradation. These are the 3 most common, the most popular repairability issues, which, let me say, which are leading to the disposal of the vacuum cleaner. Of course, the European Union has taken these kind of issues into very careful evaluation, and we have the new initiatives which have been created into the Green Deal. The most important one is the Eco Design for Sustainable Product Regulation, ESPR. What is this ESPR? Is a very large regulatory layout introduced in June 2024, and whose aim is to create a new, more sustainable and circular approach for some categories of products, mostly electric appliances, but not only electric appliances. There is also a part related to textiles and so on. Of course, I'm not saying that from tomorrow this will be the law, but what we have to keep very clear in mind is that we have to go in the direction of creating new products in a more sustainable way and in a circular economy. One of the tools that have been introduced in the ESPR is the so-called digital product passport. What is a digital product passport? It's a bunch of information, a bunch of data, which will be accessible by QR code when you go to the media store and you want to buy a new vacuum cleaner. You will find a QR code, you just scan it, and in a screenshot, you will have plenty of information. First of all, you will have data concerning the sustainability and circularity of that very product. And this information will include how many recycled raw materials have been used to manufacture that piece of application, that piece of equipment, informations about durability and any possibility to have it repaired in conformity to the right to repair regulation. And then you will also know if that application has been designed to be recycled. So design for recycling means that at the end of life, that very piece of equipment will be easily disassembled and scraps divided into homogeneous waste to be recycled or to be sent to energy recovery. Of course, this digital product passport will give us plenty of information about the sustainability and circularity of this equipment, but it will also provide the so-called sustainability score, which will be, let me say, a scoring method having some impact on the price of the sold good. If you read this norm very carefully, you can see that there is also the chance to have some discount for more sustainable products. So design for recycling and right to repair are becoming also a marketing tool in order to have our products sold most easily, more efficiently. Last but not least, of course, you will have indications about how efficiently this piece of equipment is using electric energy. So how will be the appliance of the future? How can we think about how to design an appliance for the future? Which kind of materials should we choose? The pyramid you see on the right is the so-called waste management pyramid, and it is divided into stripes, indicating what is the most important step when you deal with an application at end of life. So first of all, you have to prevent and reduce the failure mechanism in order to have the lowest number of failures possible. Once your application is broken, it should be possible to recover it, reuse it, and repair it in order to extend its lifetime. At the end of its lifetime, it should be possible to disassemble it and have it correctly recycled. And everything that cannot be recycled should be sent to energy recovery, so to thermal management, incineration, and at the end, you have waste. This pyramid is managed to reduce as much as possible the quantity of materials that are just sent to landfill and to disposal. So for the application vacuum cleaner, for the vacuum cleaner of the future, which are the most important steps that we have to take into consideration? First of all, we will need, if we have to design a vacuum cleaner, we will need plenty of details, plenty of data. So we need pieces of information. We need information about materials, about global warming potential, life cycle assessment, and so on. We are already receiving plenty of requests from our customers concerning these very hot topics. Then we will have to provide indication about durability, which is also a very important step in the direction of extending the lifetime of the vacuum cleaner. We will have to use recycled raw materials and indicate what kind of raw materials have been used into our application. We will have to design the application to be energy efficient. It will have to be as much as repairable as much as possible, because repairing means extending the life, and extending the life means reduce the global warming potential and the impact on the environment. And then it will have to be designed for recycling. So at the end of its life, it must be possible to easily disassemble it, to divide scraps and materials in a very efficient way in order to recover and recycle them very easily. Let's give a closer look to each one of these 6 steps one by one. Information. Information is very important. What kind of information are we asked for? Global warming potential and life cycle assessment. All these informations must be available for LATI's customers. So if you are working in the appliance industry or automotive industry or whatever, and you ask LATI indications about the global warming potential and life cycle assessment, at least global warming potential is something that we can already share with you very easily. We have created a dedicated team, fully dedicated to the sustainability issue, to the sustainability platform. We have also purchased a software and a dedicated database. We collaborate with European universities, and because we want to have the most reliable answer for our customers. We are not using online tools calculating the global warming potential. We are doing this job the right way, let me say the most accurate way, using software, using official databases. So do not hesitate to ask. We are using these pieces of information to provide details to our customers and to, let me say, to sustain and to help creating a new range of eco-sustainable products, the so-called LATI Echo, which are produced by using recycled raw materials, and LATI which are used by using sustainable and bio-based polymers. More than 80 compounds are already fully characterized. So for more than 80 compounds, mostly flame retardants, you can already ask global warming potential pieces of information. LATI has also joined the Desiderata project, which is a European project funded by Horizon Europe. The goal of this project is to create injection moldable compounds safe, sustainable by design. Of course, we are working in developing new, more sustainable and halogen-free flame retardant materials. But what I personally find extremely interesting is that we will work in trying to simulate what are the effects of recycling on plastics. We will simulate the effects of multiple recycling processes by subsequent extrusions, and we'll evaluate how the recycling process actually affects the quality of the compound in itself. Because as you know, each time you grind and extrude again plastics, you lose some of them of the properties, and we want to understand this better. We want to understand if it is possible to create some kind of stabilizers or stuff like that, which helps the material to keep performing despite the subsequent extrusions. We have 4 years to work on this, and we are already on track. Durability. Durability is something extremely important, because as you have understood, our applications must last a little bit more, must last as much as possible, I would say. What is the most important piece of information that customers need when you have to deal with durability? So with how long will the part last? The most important parameter is the so-called temperature index. Temperature index is used to evaluate the life expectancy of your application. The life expectancy is the time from when an application is created to when you have the onset of a potential failure. Which is the factor that is actually making our materials age? Of course, temperature. Temperature is actually compromising the performance of plastics in time, and this is well known. So if you want to calculate how long will your application last during its lifetime, and you want to evaluate the temperature that your application can survive in continuous operation, you need the following pieces of information. You will need a temperature index, you will need the so-called halving interval, the peak temperature, and then you have to provide an actual operating time, meaning the amount of time that you would like your application to work. With those 4 parameters, it is possible to evaluate the thermal endurance in continuous operation, which is defined as you see on the right, and then the consumed endurance potential, which is the amount of performance that will be consumed at the end of the lifetime of the application. With these slides, I'm trying to say that today it is possible to design applications in order to last the amount of time that we want, just by selecting the right material and using the right information. Let's see an example. Let's suppose that we have to create a component working for 60,000 hours at 120 degrees. Let's suppose that we have already the temperature index that has been achieved by measuring the thermal decaying of one of the properties, as an example, the dielectric strength. Let's suppose we already know the thermal index at 20,000 hours. Let's suppose we also know the halving interval, which is the difference, the temperature difference between thermal index at 20,000 hours and thermal index at 10,000 hours. What we can evaluate is the amount of hours that this application can survive at that temperature. Calculation says that this very material at 120 degrees will last more than 100,000 hours. Is this enough? Yes, because we wanted it to last 60,000 hours. So at the end of life, only 53% of its property potential will be actually depleted. On the contrary, let's suppose that we want to make the same exercise with 130 degrees C. What we evaluate is that with 130 degrees C, the amount of hours that the material can last is below 60,000 hours. So at the end of the 60,000 hours, this application is very keen to fail before the end of our time. And we are just talking about a difference of 10 degrees C. So you understand how important to have thermal indexes carefully evaluated and provided to customers. Why is it so important to have thermal index or relative thermal index? Because nowadays what we are actually seeing is that we receive plenty of questions from customers concerning different temperatures or different life expectancy time. So we are asked for performance at 5,000 hours, 20,000 hours, 30, 40, 50,000 hours, but we are also asked for performance at different temperatures. For this very reason, it is very important that we as material producers provide all the necessary data obtained by aging of the material in itself, so that you can make all your calculations concerning life expectancy of your application. So we are committed to provide the temperature index or the relative temperature index obtained by UL. And we are also working, this is very important, we are also working to develop the ISTM E1877 method, which is a very fast method using thermogravimetry to evaluate the temperature index. It is not the same of the above, but at least it is very, very fast. You can have a temperature index just in a few hours, but this method is still under development. And we are trying to understand how reliable it is and try to introduce it in our praxis. Recycled raw materials, another very important piece of information. How much raw materials are we using in our application? It is very important to introduce recycled raw material because this will reduce, as I said, I told you before, it will reduce a lot the global warming potential of your very application. LATI nowadays is working on introducing recycled, mechanically or chemically recycled from post-industrial or post-consumer polymers. We are working on the polymers. We are also working on the additives like glass or carbon fibers, but our biggest efforts are on polymers. Once we have new flame retardant grades obtained by recycled polymers, we wanted them to be fully approved by the UL lab in order to have new, reliable, certified, approved flame retardant products. Nowadays, we have more than 30 LATI Echo flame retardants and not flame retardants products already available, and 6 are already UL approved. Of course, it's very important to have not only recycled raw materials in new compounds, but to have them properly compounded and to be sure that they are actually performing the way we want them to. So we are working on recycled raw materials, recycled polymers. We do not like the mass balance approach. We think that it is very important to introduce really recycled polymers, but we also want to be sure that we are actually providing performing materials. If you just compare the global warming potential of a standard product and a LATI Echo, its LATI Echo version, you will see that with flame retardants, you can actually reduce the global warming potential by 30% on flame retardant materials. And if you check the LATI Echo version of the engineering products, so the glass fiber filled materials like nylon 6 or nylon 6,6, what you see is that this percentage can be increased up to 50%. So by introducing recycled polymers, you can reduce actually the global warming potential of a flame retardant compound by 30%, and the global warming potential of engineering compounds up to 50%. And this gives you exactly an idea of how important it is to use really recycled polymers in new compounds. These are the two of the yellow cards we obtained by UL on our LATI Echo compounds. All LATI Echo compounds are fully documented and industrialized. So they are not just exercises. We are actually producing them in our plants, and all of them are actually UL approved. During year 2025, we will work in introducing two very important news LATI Echo products. One for the 66G25 25% glass V0 halogen free, and the other one is for the nylon 6 V2 20% glass fiber. In 2025, we will start creating the LATI Echo version of these two materials. As a case study to show you how good and how efficient this process can be, let me share with you the case history of LATI Echo 66 mechanically recycled 25% glass fiber V0 KB3, so a phosphorus-based V0 nylon 66. This is the yellow card of the fossil-based product, Latamid 66G25 V0 KB3. And this is the yellow card, the official yellow card of the It's LATI Echo version, which is the same product using mechanical recycled polyamide 66. As you can see, it is possible to achieve the same ratings on the flammability, but it is also possible to achieve comparable RTIs. Is this enough? No, it isn't. We also want to be sure that from a mechanical point of view, the two materials are performing the same. And here you can see how comparable the two materials are. The Latamid, so the fossil-based version, is a little bit more flexible, impact resistant, but the LATI Echo is a little bit stiffer. But anyhow, the numbers are extremely close. So the LATI Echo and the Latamid have very comparable mechanical properties, and they also share the same glow wire rating, both the glow wire ignition temperature and the glow wire flammability index. So this is just to show you, to share with you how possible it is to actually create sustainable versions of the fossil-based materials using recycled polymers. Let's move into the last topic, repairability. What does repairability mean, and why is it so important? Repairability has been long discussed since a long time. It's very important as it will create the so-called repair economy. What is repair economy? Once all the appliances will be actually repairable, you can think about a new economy related to the repairing in itself, new jobs, new skills, new professionals, new shops, where you can actually bring your appliance and fix them by yourself, or let them have fixed by a professional. People may want to keep their application, their machines for a longer time because they want them to have repaired and reused rather than disposing them. This is extremely important, but how can this be done? What is the role of the material in itself for this very step? Of course, we as LATI, we are focusing on providing materials which can actually be handled more times without breaking. So we are working on the materials, improving their flexibility and impact resistance in order to have the possibility to open and close housings and snap fits more and more time, and avoid processes like welding, resin casting, gluing, or the usage of snap fits that can only be closed, not opened. We are also working on improving the hinge effect when it is possible. And then we have also to work in the direction of improving the overall performance, especially the flame retardancy of reinforced and unenforced plastics, in order to have them actually really reliable also when it comes to injection molding thinner walls like connectors or overmolding of electronic equipment. How are we doing this? What kind of products are we revamping? What kind of products are we actually promoting and redesigning and engineering? First of all, let me talk about the 66 25% glass fiber filled V0 halogen free, which is an extremely well performing product with a very low environmental impact. We wanted it to be also UL approved V0 at 0.4 millimeter in order to have it usable also when it comes to injection molding of very thin walls. The new material is called V0 HF1X, and it is fully approved also down to 0.4 for UL94 V0. This is the first effort we made in the direction of providing new flame retardants. Then we wanted to revamp an old, very fashionable product, which is a nylon 66 halogen-free unreinforced flame retardant. So we took this guy here and we wanted it to be polished and revamped. We wanted it to be actually a little bit more performing and more appealing. So we knew that the material in itself had very good mechanical properties, very good elongation at break. We wanted it to have also new RTI, so new relative temperature index, down to 0.4. We already achieved the new mechanical RTIs, 85 and 100 degrees C, and we're going to be given also the electrical RTIs, which will be at least 100 degrees C. You do not see these new ratings on this material right now because this process will end at the beginning of 2025. But at least I want to share with you this very important decision. We want to refurbish, revamp, and boost unreinforced polyamides flame retardants for repairable application and low thicknesses application. On the same track, we see the efforts that we have performed on nylon 66 impact modified, that is the meaning of PX, V2 material. Very good product. We wanted to have brand new rating down to 0.4 material, new glow wire, new application also, and new performance evaluated also at the VDE, glow wire ignition temperature and flammability index. Also in this case, you will see the updated yellow card and updated VDE certification at the beginning of 2025. Also in this case, I would like to focus your attention on the extremely good performance from a mechanical point of view of this unreinforced and toughened polyamide 66. Last but not least, I want to share with you also some news concerning our 3D printable material, which are coming actually from our LATI 3D lab. LATI 3D lab is a lab dedicated to creating 3D printable from filament or granule materials that can be used to produce parts. I'm not just talking about ABS or PLA, I'm actually talking about proper structural, flame retardant, conductive, self-lubricant, and detectable materials. Our 3D lab is capable of creating filament, offering real performance from a structural point of view, flame retardancy, and so on. Here you can see the two technical data sheet of a nylon 6 30% glass, nylon 6 50% glass for 3D printing, and then a copolymer 666 for connector manufacturing, which is also V0, and of course another special product, PPS for 3D printing with Kevlar inside. Nowadays, we can provide 3D printable filaments made out of PPS, PEEK, polysulfone, self-lubricant materials, flame retardant materials. We have more than 170 different 3D printable materials that can fit any kind of application and requirement. It's really unbelievable the effort that LATI 3D Lab has done during these years. I strongly recommend to go and check the LATI 3D Lab website. You will find plenty of interesting materials and a very efficient technical service answering any kind of question that you may have. Now, let's sum up what we have seen till now. First of all, we will have to rethink the future of applications and materials in a more circular way. We will have to think about durability, repairability, recovery, and recycling of our application. It is really very important that we start today, not to be in trouble in 2 or 3 years. So, first of all, what we have seen is that the biggest chunk of the global warming potential of any material is related not to the manufacturing process, is related to the raw material in itself. And this can be much higher than the global warming potential generated by the usage of this very application. This is the first very important input, saying that we have to save raw materials. We have to save the material in itself. We will have to do this because the European laws are moving in that direction. So we have to work in the direction of durability, repairability, and recyclability. These informations will be uploaded in the so-called digital product passport and the so-called sustainability score, which will be a QR code placed on your appliance when you go and buy it. So it will be a very important and discriminating parameter when it comes to purchasing a new application and a new appliance. We as LATI are committed to provide all necessary pieces of information concerning sustainability, so the global warming potential, LCA when possible, and so on, and when possible, all data concerning temperature index, which are used to evaluate the durability of the application. We are also working in introducing new recycled raw materials like nylon 6, 6, PBT, polycarbonate, and so on, in the new LATI Echo product range. Nowadays, we have more than 80 LATI Echo compounds, which are the clones of the fossil-based materials, offering outstanding performance. You can find some of the datasheet on our website, not everything, but you could just go and check it. And then we are working on improving the performance, mechanical and flame retardancy, and the ratings of some strategic products, including especially the unreinforced plastics, in order to provide materials that can be used to design injection mold parts that can be actually repaired, opened, and handled in a much safer way. Of course, as I told you before, we are also providing new 3D printable materials that can be used to print spare parts in order to reduce, to some extent, the shelves full of spare parts which are costing actually, and which are also getting old just sitting there on the shelf. I strongly encourage you to keep your eyes on the LATI website. I hope I was able to give you a decent introduction of what LATI is doing in order to let you have the materials and the tools to design your applications for recycling and for more durable usage and for repairability. And I thank you, of course, and I invite you to join the next webinar of LATI, which will focus on the 1 year of work concerning PFAS replacement, PTFE replacement. It will be a very important, I would say, a very important webinar. We will give plenty of news concerning PTFE replacement. It will be on the 18th of December, and all of you will be welcome, of course. Now I will welcome any question. If you have any, just write them in the chat box below. We have the first question is it's a very complicated one actually. The difference between thermal index and relative thermal index. This is quite complicated actually to explain just with no reference. All in all, I can say that thermal index is describing how the property of the material in itself will decay in time. Relative thermal index is the same thing, but the evaluations are carried on with a, let me say, with a control material. So it is not the temperature index of the material in itself, but it is the temperature index of the materials in comparison to another material which is used as control. Most of the time they can be, let me say, they can be used in the same way, but they are not actually the same, as they are not even obtained in the same way. Okay, the second question is how can we guarantee the mechanical performance on recycled materials? Yes, this is a good one. Actually, we cannot guarantee anything. Of course, we are actually monitoring the performance of the raw materials that we purchase. We want to be sure that the compound in itself is performing the right way, and so we are carrying on an extensive test on the new LATI Echo created. But of course, as you can imagine, when you use recycled polymers, normally you have to accept some kind of diminishing of at least mechanical properties, and this is the hard part of the job, because actually our work is to, let me say, is to limit as much as possible the reduction of mechanical performance. So we are working also on stabilization, on the kind of glass fibers to be used, and so on. So it is really very, very important. The third question: are we? No, we are not involved in recycling in itself. LATI does not recycle scraps. LATI does not handle waste or any kind of material like that. We purchase everything. We buy recycled raw materials from qualified suppliers, which are selling us the raw materials with full documentation, and also from a compositive point of view, we want to stay on the safe side. We do not do this job on our own because it's not our job. We are compounders. We are not recyclers. So we are not recovering the materials. Okay, so if you have any other question, please send me an email. You can see my email address just in this slide. I thank you for your attention. I really hope I was able to give you a decent overview of the future of appliance, of right to repair, and what LATI is doing. I thank you for your attention, and I strongly invite you to follow LATI on LinkedIn, YouTube, and to subscribe for the forthcoming webinar concerning PTFE replacement. Thank you all for your attention, and see you next time.